Hello, this is section 4.6 for Calc AB, and we'll be talking about the natural logarithmic function integration. So the whole idea is to watch out for this 1 over x. All right, and it's really easy to identify because if you were to try to move the x up and make it x to the negative 1 and do the power rule where you add 1 to the exponent, divide by the new, well, you'll be adding 1 to negative 1, which gives you x to the 0. And then when you go to divide by 0, you're like, oh, this isn't working. What's going on? So if you don't catch it right away, you will if you try to use the power rule. But if you have 1 over x, that antiderivative is the natural log of the absolute value of x. Now, it is very important that you put the absolute values there. There is the only restriction on the domain of that integrand is 0. But as soon as you do the antiderivative natural log of x, x has to be a positive number. So you have to make sure that that domain from your integrand doesn't get carried. You have to fix it so that you only get positive numbers in that argument there. Okay, so you just have to be really careful and make sure you put those absolute values. Sometimes you don't need them. Like if it was x squared, you know it's always going to be positive, but you're always safe by putting them. Right? And then if it's something other than just x, and so this is just saying you can use substitution and watch out for, you can, when you do the antiderivative, it's the same thing if it's u, okay? All right, so here we go. So find the antiderivative of 3 over x dx. 3 is just a scalar, so move it out in front. 1 over x, that antiderivative is the natural log of the absolute value of x. And that's what it is, and that's your answer. So this becomes one of your basic antiderivatives, basically, kind of like the ones we did in section 4.1. This is just one that you have to know and be able to do. Right? Now here's where it gets a little more complicated. So set that denominator equal to u, so we can do substitution. So do the du, like I showed you in the last section. You get negative 5 dx. Do you have the negative 5 you need? No, but you can easily put a negative 5 in that numerator and divide by the new, that negative 5 to make it legal. So there's where that negative 1/5 is coming from. Then you get 1 over u du when you do your substitution, which is perfect because 1 over u, that antiderivative is natural log of the absolute value of u with the scalar in front. And then, of course, never leave an answer with u in it. So replace the u with the binomial, and that's your answer, plus c. All right. So find the area of the region bounded by the graph between 2 and 5. Okay, so we wrote the definite integral, set the denominator equal to u, because du ends up being 3x squared dx. We had a 6x squared dx, so we had to multiply by 1/2 in the numerator to get the 3 we needed, and we had to put a 2 out in front. That's kind of backwards from what we normally do, but it still works. Now, when I went to write the new integral in terms of u, notice it's a definite integral, so I wrote the new bounds in terms of u. So 2 times, and then my new bounds integral from 3 to 120 of 1 over u du. So this antiderivative is natural log of the absolute value of u. But remember, the beauty of changing your bounds is you don't have to bring x back into the problem. You just leave it in terms of u, and then you can plug in 120 minus natural log of 3 and get your answer. Okay? All right. Now, one thing I want to point out, there is kind of a shortcut if you haven't figured this out already. Whenever it's a linear, do you happen to notice that you can almost kind of skip the substitution step? This turns into u, and you always end up dividing by the slope. So a lot of students will get to where they're good enough where they can realize, oh, if this is linear, you still have to check to make sure it'll work, but you can often skip and say, okay, well, I know that's just going to be natural log of the base, and I just need to make sure I divide by the slope. If you're getting to that point, feel free to use that little shortcut. That is perfectly fine. Okay, so now we're just getting into seeing that, okay, yes, it's the denominator that I want to make the u, and then the derivative being in the numerator, and then just checking it, making sure 2x minus 7 dx, you're good to go. Now you can do the 1 over u du. Same thing here, sine and cosine. Yeah, these are pretty straightforward. Now this one, when you set the denominator equal to u, 2x cubed minus 9x, and you do the derivative, 6x squared minus 9dx, go back up here and look. Uh-oh, I have a 2x squared minus 3. You have to make sure you can fix it with a number. And can you fix that problem? Yes, just multiply the entire binomial by 3. But to make it legal, you have to put a 1/3 in front. If it's not fixable, if it's like, let's say this was an x squared minus 3, you'd be in trouble, all right? You wouldn't be able to solve it. Okay. So here's that trick I was telling you about. So it's a linear function, so you can kind of skip this step if you feel comfortable. Just skip to natural log of the absolute value of the base. You just have to make sure you divide by that slope, and it works, all right? But don't do that if you don't feel comfortable, all right? Okay, I think this one's pretty straightforward. I'm looking for anything weird. Okay, find the indefinite integral. So this is one where if you try to keep doing what we were doing, you set the denominator equal to u. The derivative is not in the numerator. Okay, so here's another strategy. When the numerator is greater than the denominator, you can do long division and rewrite this integrand. So we did long division over here, and we get x plus 1 minus your remainder, which was -1 over what you divided by. So now these first two terms, you can easily do those antiderivatives. Just use your power rule. 1 turns into x. And then here's where you can use your natural log, or you can do that linear trick I was telling you about. Since it's linear in the denominator, it's natural log of the base. Notice the absolute values. And then you just have to divide by that slope. And if there was a scalar or if there's a number up here, that would of course be up there as well. Now there is a plus c, it just got cut off there. Okay. All right, solve the differential equation. So get your dx over to the other side, do the integral of both sides. And that's all, it's nothing. Okay, and then here come all your trig functions again. So doing the antiderivative of sine and cosine, remember our little jingle, sine, cos, minus sine, minus cos, but just going backwards when you're doing the antiderivative. But then remembering some of these. Now you have to be careful. So tangent of u, I'm surprised I don't have that little proof there. If you think about it, remember tangent's really sine over cosine, so you'd set cosine equal to u in the denominator, so its derivative is negative sine, which is in the numerator. So that's where that whole natural log of the absolute value of the base is coming from. And same thing with cotangent, natural log of the absolute value of sine. Those you could easily figure out if you forgot them. Now these two you'll have to make sure you memorize. So the antiderivative secant, antiderivative cosecant. Okay, so now this one you had to do a little trig identity real fast. Cosecant squared minus 1 is really cotangent squared, which the square root of that is cotangent. Then you can turn around and use your rule here. Okay, and notice I didn't have to change the bounds because I never rewrote that definite integral in terms of u. You only have to worry about that when you're rewriting it in terms of u. Okay, so this lesson is not bad. You just have to practice. You got to get used to, this is just another strategy that you need to think about when you're tackling an antiderivative. You of course always look to see, is it a basic antiderivative, something from 4.1? Okay, is it something I could do substitution with? And this is what you're using. This is just a basic, just a little bit fancier substitution type problems. Where it's 1 over u, you have to recognize, oh, that's natural log of the absolute value of u is the antiderivative. So it's just one that you have to be ready to use if you need it, okay? All right. Okay, please, please, please do your homework and email me if you have any questions.